Hello everyone. In this lecture, let us have a look at feature matching using HOG. Let's open up our Anaconda Navigator. Inside our Anaconda Navigator, let us open up the cmd.exe prompt. Now, let us install our SK image. So you cannot directly install the SK image like you did your OpenCV. If I do so, this is the error message I will be getting. The error message will simply say that there doesn't exist an SK image library. But the SK image library in Python is under the name of scikit image. So when we run this, it will install the package which is required for us. Depending upon your net speed and computer processing power, this method may take a minute or two. So once your SK image has been installed in your computer, please open up Jupyter Notebook. So now that the installation is opened, I am going to open up my Jupyter Notebook. So in Jupyter Notebook, let us first import our CV2 library. Once we have imported this, our next step is to import the data visualization library, which is from matplotlib. We will be importing pyplot as plt. And in order for our plot and background etc. to be proper, we will also be providing the modulus symbol along with it matplotlib inline. The next step what we will have to do is importing our image processing library. This will be our SK image. But from our SK image, we will be needing to import only a few libraries. So from SK image dot feature import HOG. Also from SK image, let us import data and exposure. So while this is imported, our next step would be to read in an image. For the image which we will be using for this operation, I will be using my favorite image, which is scenery.png. Now that we have finished reading in our image, what we have to do is we will have to perform the HOG operation on the image. So to perform the HOG operation, let us create two variables, fc, image underscore HOG. Okay, now we will be using the HOG function. So this HOG function takes in 5 arguments. I will be explaining the arguments one by one. The first argument is our source image or our read-in image, which is img. The next argument is the number of orientations. This we are going to be assigning a value of 8 for this purpose. After orientation, our third argument is going to be number of pixels per cell. And for this, I'm going to give a number of 16, 16, which means that in each cell there is going to be a 16 cross 16 pixel setup which is going to be present. So our fourth argument is going to be the number of cells per block. Okay, so over here I'm going to give a value of 1, 1. Our fifth argument will be a condition for visualization. Okay, so I'm going to say visualization or visualize to be more precise. this is going to be equal to true. Our sixth argument and a final argument is going to be multi-channel, and this is also going to be set to true. So because my whole line is going to be so much that you guys are not going to be able to see the text clearly, I am putting the multi-channel, which is equal to true, argument in the next line. So let's run it and make sure our program is correct. So I have not gotten any errors. This means that the HOG process has now been applied to my image. Our next step is to rescale the image. So let's create a variable called rescale underscore intent. Okay, and we are going to be using exposure dot rescale underscore intensity function over here. This function takes in two arguments. The first being the image on which the HOG process has been applied, and we have gotten our output. So here that image is going to be img underscore HOG. The second argument is going to be the range, which provides the maximum and the minimum intensity value of our input image. So in underscore range is equal to minimum value will keep it as 0, maximum value will keep as 10. So now let us run it. So that now we have finished even rescaling our image, our next step is to display the original as well as the HOG applied image. So how do we do this? We will not be using our usual setup where we use cv2.imshow original image, cv2.imshow operated image, then we say cv2.destroy all windows. This is not going to be used here. We will be using the data visualization library matplotlib over here. So let us create two arguments, figure comma in a tuple a1 comma a2. This is going to be equal to plt dot subplots 1 comma 2 comma fig size is equal to 12 comma 6 comma. Now I wanted to tell it to share the x-axis and the y-axis. So I'm going to say share x is equal to true. Similarly, share y is equal to true. So now that I have finished this, now I have to assign a1 one set of image and a2 another image. So a1 dot axis is going to be off. This implying that I do not want to see the axis values in my image. Next, a1 dot imshow is going to be my original image, so img. Next, I'm going to assign a title. So a1 dot set underscore title. This is going to be original image. Now let us do the same thing for our HOG image also. As you guys can see, I have now created the code for displaying the A2 image, and I've also shown plt.show over here. So let's execute it and see our output. So the output you guys are seeing is the first, the original image, second, the feature matching using HOG has been carried out. So what you guys can go ahead and do is 1. Try different images. 2. You guys can go ahead, try changing the orientation, the number of pixels per cell, the number of cells per block, and also you guys can try changing the minimum and maximum value of intensity. Thank you. See you guys in the next lecture.